Pozdrav svim pratiteljima, fanovima i članovima CroCube-a. Dobrodošli u treći posebni intervju. Danas pozdravljamo Marcela Frajta. On je Spacemanicovog Lead Space Engineer i zapravo osoba s najviše iskustva u našoj misiji. Marcel je iz Slovačke, stoga će intervju isto biti na engleskom. Marcel, welcome. I would ask you to say a couple of words about yourself for the beginning.
Yeah, thank you for having me. In a short introduction, I am Spacemanic's lead space engineer for our satellite missions, and in CroCube, I will be kind of leading the team in the mission design and the satellite design, and teaching the team how to work with the Spacemanic satellite platform, and hopefully bringing the first Croatian satellite to space.
So, how many missions have you actually done before you joined CroCube or started CroCube in a sense?
Yeah, so I have been directly involved in six satellite missions so far. Some of them as part of my studies, some of them as a volunteer during my university studies, and some 3 missions completely professionally after joining Spacemanic.
Can you tell us a bit more about that? How do you actually plan or design a satellite maybe?
Yes, well, every big project and specifically every satellite should start with an idea, and some ideas are very big and some ideas can be quite small, but not less important. So from our experience, and you've probably heard already that CroCube aims to be a CubeSat satellite, so a very, very small and quite simple satellite. These projects are usually in 3 categories: scientific, technical, and kind of just for popularization. There is no better or worse category, because every satellite is important on its own. So CroCube aims to be a popularization satellite that will, as we discussed with the team previously, and aim to take pictures and provide these pictures to public and bring some sort of space education to Croatian people and students and even children. So with this kind of idea, we can start thinking about what this kind of satellite needs, and we go into some more technical questions. First of all, is the size, and with this mission, we can quite easily determine that a 1-unit CubeSat, that is just a cube of 10 centimeters, is enough and sufficient. Some maybe scientific missions or more technology aimed missions can have bigger requirements and may need larger satellites. So they go towards bigger CubeSats or even beyond the CubeSat mission. So with CroCube, since we know that 1 unit is okay and just the 1 cube is enough, we can start thinking what we want to put inside the satellite. So for example, we do know we need cameras to take pictures, so we can see what's available, what's on the market, what can we utilize on this mission, maybe some kind of new development, and with that we can then start thinking about the power consumption needed. As we all know, there's no power plugs or some kind of power lines on orbit, so we usually utilize solar power. So we need to also assess if this size and the amount of solar panels we can put on the satellite is enough, and kind of design or pick from nowadays available components the sufficient ones. So if we go through these kind of steps, we have an idea what needs to be in the satellite, and we can start procuring and making the decisions what we want to design ourselves and what we can buy from some suppliers.
So, although you buy stuff, you make some of the components on your own. Not everything can actually go to space. We have talked about this before, so the components and the satellite actually needs to be tested. Can you tell us a bit more about this?
Yes. So every satellite needs to be qualified to fly to space, and this is up to our so-called launch provider. So this company that can put us on the rocket gives us some guidance and some rules to follow. It's with every mission it is a bit simpler and a bit more streamlined as the whole space industry evolves. So from the satellite perspective, we need to test it to vibrations because sitting on a very big and explosive rocket is very demanding mechanically. So these are the vibration tests we need to pass, and it really depends on whether we are flying on SpaceX rockets or the Ariane rockets. These tests differ a little bit. Some are more aggressive, harder. Some are a bit softer.
Yes, I
The other
wanted to
very
come to
important.
that. So we are launching with SpaceX. You can finish this, but we can. What does SpaceX actually require from us to test?
Yeah, so this is a bit general. It really differs only in these levels of testing. So I don't really remember on top of my head the numbers, but for example, last time I think we tested with SpaceX rocket the static load to 16G, and if I remember correctly, for example, Ariane rockets, the European ones are a bit more demanding, up to some 20G. But it really depends on the exact mission. So, but these tests are nowadays unified, I would say. So the vibration is the important one, the most important one, because we need to make sure the satellite actually survives this journey to space. And the second very important kind of test is the electromagnetic compatibility, and this is for CubeSat very simple, and it's a matter of a statement and a verification that the satellite is during this rocket launch turned off in the deployer. So these are the most important two information. And beyond that, we are usually interested in some thermal performance, because the satellite, as it travels through our sky on orbit, it goes very fast from sunlight to shadow and experiences a lot of thermal stress because of the changing temperature, and also the side which is looking towards the sun, which is sunlit, is a lot hotter than the opposite side that is in shadow. This difference can be some 50 degrees Celsius or even more. So this kind of difference is also something we need to acknowledge. And what we usually aim to do is thermal vacuum tests. So we put the satellite in a vacuum chamber and try to simulate as little air pressure as possible, and put the satellite through this kind of thermal cycling. So we bring it up to some 60 degrees Celsius of temperature, and then down to some negative 20 degrees. So the satellite really needs to survive extreme temperatures, and with different orbits and different maybe scientific demands, this can be even more, even higher or lower temperatures. But this kind of negative 20 to plus 60 is the starting point. And yeah, I'm thinking what else is there. Of course, functional tests, apart from all the software and the procedures that the satellite needs to do, like taking pictures and properly communicating via radio. We also, if we have some mechanical parts, some moving parts, we need to test them beforehand. We need to, at least antennas are deployable. So these are kind of hidden inside the satellite, and after deployment, they get deployed, get shot out of the platform. So this needs to be tested if everything functions properly as it should, and if it functions automatically, because we cannot really choose where the satellite is deployed from the rocket vehicle. So it can take some time to get in contact above our designated ground station for the mission. So we also need to be sure that all these automatic procedures, especially after the deployment and in the first start of the satellite, are functioning properly.
So the step before the very launch is the integration. Can you walk us through the integration process a bit so we can understand it better?
Yeah. So with integration, there's two things we can mean. It's the first is the integration of the satellite itself into its final form. So preferably in a very clean environment, and even a certified clean room. We build the satellite from its components. So these are usually electronic boards or PCBs that we put together inside the satellite frame. And after that, we usually travel with the satellite to the facility of the launch provider, which might be, from our experience in Germany with the ExaLaunch company, we have a very good experience with. But you can also, these engineers, the integration engineers, can also have the need to travel all the way to America, or with European launches even to Kourou, which is a French island near the equator. So on site now with the satellite built, it's very simple because the satellite is turned off and ready for the first deployment. So all the timers for automatic operation and deployments are already in place, and it's a bit funny because we are checking during the whole process if the satellite is turned off, and we would really like to know if everything is okay inside, but we cannot really turn it on. So it's a bit mysterious, every part of this process. But with the guidance of the launch provider, we usually go through 2 or 3 parts. The first one is this kind of final checkup if during transport nothing got damaged, no solar panels got damaged or something like that. All the covers, for example, if we have optics, during transport we cover them with the appropriate tape. So we need to take these off. We need to, for good measure, document everything, take photos of the satellite to be sure that everything was correct. And after that, we usually take the satellite, put it inside the deployer rails, and we kind of simulate the deployment first. to make sure that everything fits nicely, the satellite has proper dimensions, there's no kind of issues, no parts are unexpectedly sticking out and in contact with maybe a second satellite in the deployer or the deployer itself. So we kind of simulate very softly this deployment, and when this goes right, we do the final integration, put the satellite inside the deployer, maybe with another team with their satellite, since there's a lot of space in the deployer, and it just gets closed, and we say goodbye to the cube.
Okay. So before we say goodbye for this interview, the last thing I want to ask you is, do you believe this project can actually do something beneficial for Croatia, both in long term and in short term?
Yes, I believe this very much. I have seen this happen, especially in Slovakia, where the first Slovak satellite called CroCube was this kind of project from enthusiasts, and the fruit of this we see nowadays. I think it was last week that Slovakia finally joined the European Space Agency, and this brings a lot of new opportunities for companies to get involved in the space industry and space business, but it also opens a lot of doors for students from even primary schools all the way to high schools and universities to do great things. And even though CroCube aims to be a bit, maybe some would say, simple, it is very important for the team to go through the whole process and see the whole process unfold. Some projects tend to aim maybe too high sometimes, and in this kind of development we often make decisions to leave something simpler, to make a step back sometimes, and leave things in their simple form or simple electronics. But we need to go through the experience first. So the CroCube mission, I hope, will bring a lot of experience and know-how, even if just kind of doing the step of actually building and finishing a project of this kind of size. Maybe not dimensions, the physical dimensions, but the project size is great. And every year we don't go through this is a year missed, because the space, especially the space industry, is moving at rocket speed, to say.
Let's hope the Croatia will follow Slovakia's example then. Thank you, Marcel.
Yeah, thank you for having me, and I'm looking forward to working with the Croatian team on this one.